Okay, so welcome everyone, and then I would say, Professor Albers, you can start directly.
Yes, hello everybody. We have very interesting times with the COVID virus. On the one hand, it is reducing our life and influencing our life very much. But on the other hand, I think it gives also some impulses in new formats and digitalization and so. And therefore, I'm very happy that we can do the workshop. Deep in my heart, I don't know if Dorian is in here, deep in my heart, I would say I would prefer to be in a physical meeting in the lovely place at your hometown. Okay, our part today is managing complexity of socio-technical systems, as a contribution of advanced systems engineering. We want to give you a little bit an input from research which is done in Germany in a very wide manner to this aspect. And then afterwards we want to have, in short words, some workshops to identify maybe common research interests. Important, if I speak in the plural, I mean my dear colleague Roman Dumitrescu, who is with me in the advice project, and we are doing research together. Roman, do you want to say a few words, but you start then later?
Also, a warm welcome from my side, and I'm happy to give a talk now, and I'm looking forward for the discussion and workshop, but I will continue then after you, maybe.
Okay. Yes, let's come to the next. Over here is an agenda, the timeline a little bit. I think we want to make a short introduction. Then Roman will speak about the research needs, where we did a very big study in Germany and in international study to aspects of systems engineering. Then I want to present a few items of the ISA research, actually more as an impulse. And then we want to do the workshops. Simon Rapp will organize all that. And at the end, we want to see, we want hopefully have a few interactions and a few interesting research aspects for the future. Okay, next slide. First, I have to say a little bit about history of advanced systems engineering. Advanced systems engineering, this word we created, Professor Gausemeyer and me years ago, far before 2008. And then we started with a workshop in the REGAP, the German research organization. It is the Renaissance of systems engineering in 2008. This was the starting point, and you see already what happens. We have now 2020. It is a little bit long ago. In the TMCE conference 2012, we did first papers to the aspect of advanced systems engineering, and we started together with Jürgen Gausemeyer, and I think Roman was also in the party again, a common research project between Paderborn and Karlsruhe on this part. At the end, we failed, and my feeling was that at that time maybe we are a little bit too early with our topic. And but already at that time I said we will come back to this aspect of advanced systems engineering, and so we did. In 2017, the Architects, the German Academy of Technical Science, took over this topic of advanced systems engineering. We did first workshops to this topic. Jürgen Gausemeyer and me were became active in this field. And then the next step was that the German Federal Ministry of Education and Research made a call, managing complexity. You can read it. This is a little bit our part, what we are doing now and where we're presenting our. And so it is, we were successful to bring this topic again on the line of the politicians. And in June 2019, we started with our advice project. Roman will report a little bit about that. And just now, a few weeks ago, a big strategic activity started with RSA, and the meaning of Acatech, of our core team in Acatech, is that this topic will be as big as Industry 4.0, and we want to develop it. And the government started in October 2020 a big research, the first big collaborative research project with, I think, Roman, you know it better, eight big projects, and in the volume of 50 million funded money plus industry money. So it's a really big research project in Germany on the aspect of advanced systems engineering. And so it makes very much sense to go in this direction. And for us today, we want to present first ideas, first results from our survey and our analysis, and invite other researchers, also international researchers, and also colleagues from industry to join us in this initiative. So I gave over to Roman.
Albert, and actually I can start straight from this point of this announcement of the Federal Ministry of Education in Germany last year. Simon, when you go to the next slide, then we can see that in 2019 this announcement was done, which was actually from the same topic that we are carrying out today in this workshop. And Albert already mentioned those different ACE projects, 8 already starting right now, more to come, I think. And this advice project, which I will introduce, is more like a scientific supporting project, which has several objectives, for example, the support of those projects, but also to look for an engineering strategy for tomorrow. And maybe we can go for 1 second a little bit further into the past. I'll go back to the slide before, please, Simon. Then we will have to think that this there has to be a reason for the German government in order to make up such an announcement and to look for projects with a complete volume of 50 million euros and maybe more. And the main reason is that everybody's feeling it, and I think we see it right now, also due to COVID, a little bit more clearer, that the added value is changing. So the added value of tomorrow will not be the same as it was in the past. We have, of course, the digitalization, which drives not only the products, as we will see, but also the process of fulfilling this added value, and those value change will dramatically change. And we have the globalization, which goes further on. And now we can see that volatile markets, or what we all call the VUCA world, is getting really a reality, maybe a little bit faster due to COVID, that we're also talking about more resilient value changes, more different markets, productions, plans, and different markets. So all those topics was the main reason why we also have to think about the role of engineering, because we were discussing maybe about the production, which was main focus at the beginning, at least, of the Industry 4.0 discussion and work. But we have to think about the process in order to get to new products, to new systems, to handle and manage this complexity maybe by new systems, and of course, in the end, to earn money with those systems. And now please go back to the next slide. And this is the main setting of the advice project, which has 3 different, I would call it, activities to carry out. The first activity is the research. So it's a scientific supporting project. This means we do a lot of scientific analysis, a lot of benchmarking according to what is happening, how's the engineering looking in Germany, maybe in other areas of this world. And we do a lot of interviews and discussions with experts. So we carried out way more than 100 expert interviews already, and looking for information and interesting theses that we can prove or work further on. The second main activity is to support those different projects, which we already mentioned. This means that we support those projects by giving them clear definitions of certain aspects, by making clear that they or giving them a possibility to communicate and to cooperate to each other, to look for another help for specific topics, and in order to look for synergies, in order to have common objectives and common results that we can build up together. So, and the third aspect is maybe the most interesting, but maybe the most difficult activity to carry out, is to work out a strategy, especially for Germany in this field of engineering, and what is the role of engineering in the future. And this is where we have the first results, and which I would like to present to you, because we have carried out already several interviews in order to have what we call right now the analysis of the current situation in Germany, at least, but also in comparison to different areas in the world. So when we go to the next slide, then I can give you a short overview how we are working on this first publication, which we will publish at the end of this year. So the databases was run about 100 expert interviews, a third, you can say probably a third from the academic, with an academic background, 2/3 more from industrial background, crossing different sectors, industry sectors. A lot of them experts were from automotive industry, but also mechanical plant engineering, IT industry. So what you can find at least in Germany. But we also had started already some expert interviews in other areas, not only in Germany. And this is very important to see that the company size of which we were having this study, or we were carrying out this survey, was more or less more larger companies. So companies who already have done something in the field of, how to say, advanced engineering. So the interviews were carried out between August and the beginning of this year. And we have some preliminary results where I can just give just a few insights, but we structured our study into 3 pillars: the advanced systems, so the products we want to develop; the systems engineering, so what is the capability in systems engineering right now; and the advanced engineering, which we will mean, are there new approaches, new technologies used in the engineering. So when we go to the first pillar on the next slide, then we will see that there were four major results when we were looking at the advanced systems. So we were discussing and asking all the experts, how will their products will look like and how they will evolve during the next years. And those 4 aspects are, well, first, the first aspect were that those products getting more and more intelligent. They were using more and more technologies, especially of the field of AI, so artificial intelligence, but also due to robotics and automation, in order to develop what we call autonomous systems. And the second aspect, that those systems need more and more human-centered design approach. This means that more focus will lie on the interconnection or interaction between the system and the user. The third aspect was that those systems will be dramatically, highly interconnected to each other, but not only in the way that there's a very high number of connections, but that those connections are dynamically changed. For example, that there is, for a certain temporary set of time, several systems will build up what we call system of systems. For example, the convoy building of different vehicles, for example, is such a system of system for a certain aspect of time. The fourth aspect is that we realized in our interviews, and this is nothing new, but it was very often emphasized by those, especially by the companies, but also by the experts from the academic field, that a lot of functionalities and services will be realized due on a databases and data that is gained during operation mode. And this leads also to a new kind of businesses and business models, and the role of engineering according also developing not only hardware products or software products, but a complete closed software hardware system with a high number of database services. Gets also the question, how will those systems develop? Can it be done with the current existing methods? So this, according to the advanced systems, when we now look at the systems engineering field on the next slide, there were also certain results, for example, that the very often named integrative development of product and production system is very often addressed, but it's not that realized in the industry. It's still a sequential process. And we also realized in our interviews that systems engineering is not that widely established as an overall approach. Only single approaches are very often used, and only or more often in huge, bigger, larger companies. And where it's introduced, it's very often a change management process that is necessary in order to establish systems engineering, which is very individualized to the needs and the conditions of the company. What was also interesting is the field of model-based approaches. There's a lot of people are talking about model-based systems engineering, also our experts which we interviewed, but this is not the approach already fulfilled as an overall approach in the systems engineering. So a lot of things are still on a paper-based approach, or as I already said, more as a sequential process that's fulfilled. So the last pillar is the advanced engineering on the next slide. And this is very interesting because this was where we asked the companies and all the experts also from the scientific field, what do you believe that the engineering will change, or what are new drivers of the engineering? And the huge topic was the ICT, so the information communication technologies. So a lot of people were discussing how AI, for example, could change the engineering, how other ICT technologies could change the engineering approaches, augmented virtual reality for testing, for example. Very interesting, but there's not the answer right now. But this seems to be a huge, important aspect in the change of engineering. Also, how product lifecycle management, digital and virtual engineering, systems engineering will fit together in the future, but it's still different approaches in companies very often. And then we also have a point which was not that about those technical aspects, it was more about the methodological aspects in engineering. So how to increase the creativity of the engineers, the creativity of finding new products, new systems that will be successful by having all this way huger complexity and to handle this. We are very often heard about agile methods which play a role, but also other creative technologies, techniques are very interesting, and very often people were saying, or experts were saying, maybe we have a look closer in other areas, because in Europe we do very systematic engineering, which is very good and very successful, but maybe we also have to look at other approaches, maybe what's happening in other parts of the world. And this is, I think, very interesting to have a closer look also at those aspects. And this is what we do in our advice project on the databases that we can really build up over the next years, because this advice project will run at least as long as all those projects. So at least from now on, still 3 to 4 years. So it's still a lot of work in front of us. And this is the setting also for this workshop. When we look at the next slide, we having, according to those different pillars, also had a look at the different workshop groups. So we have a workshop group which is more focused on the systems, so on the advanced systems. We're a workshop group more focusing the systems engineering, the complexity management, and 2 groups which are more focusing those topics which I just mentioned, the digital engineering with new technologies, but also on which kind of new innovative methods can be used. And the last group will focusing more on a cross-sectional topic, the competencies which are necessary in the companies, and of course the aspect of education, which is very important also from the academic point of view. So this from my side is a short introduction from the advice project, and I think I will give back now to Albert, who will present something, because the good thing, we don't start from scratch about this.
Maybe a short interruption from my side, because we were not sure how many participants we would have, and so to get a good guess early, who would be interested in what group, and maybe how many groups do we need. We have Paul in the chat. I hope you can see it. If you go to Paul's and then session, and then while Professor Albers is making his short presentation, maybe you can also participate in that poll so that we are prepared right for the next slot.
Yes.
Okay.
Thank you, Simon. This is an important advice. The number of groups is a little bit depending on the participants. Maybe we will have only 3 groups to these 3 pillars. That's also okay. No? It depends on. Okay, yeah, let me just take up what Roman said. For me, it was a very interesting finding in this very wide study in industry and also in the scientific community, but very special the results from industry, that we found much more questions than solutions. Yeah, so there is a real necessity of research, of common research, and helping to overcome all the aspects in the future. And therefore, it makes a lot of sense to go in this direction. And Roman, we can say it. We have every time when we speak with companies, we do a lot of also small work groups with leading people from companies. And where we present these topics, they are very much interested and they are very much open, but most of them have no solutions up to now. And that's what we want to trigger also with our advice project. And this is also new, Roman said it already, for our government. Up to now, very often these big research projects of common research of companies and scientific guys were separated in single project. And what we want to do is advise to be a little bit helping them to come together and also to condense a little bit the findings so that the complete aspect of advanced systems engineering goes in a good future. And we are very sure that in the future we will have a lot of more other common research projects from the government on this field, because it's tremendous important to do something. And what is also an interesting finding is, I think it's also a little bit new in the set of this research, this triggering on the human in the center, human-centered methodology, human-centered solutions. I think this is also a very big impulse. And in our interviews with the companies, we very often heard, yes, we know we have to do something, but what do we do with our teams? How can we get the teams with us in this new future? And I think, Roman, this would be also an important point in our research. Huh? Okay, yeah, let me start. I want to explain a little bit with a few slides, some basic ideas. Here, this overhead shows a model of the situation. We have very good specialists in disciplines, in product engineering, design, software technology, and you can go deeper in that specialties. But the future will be that we have to bring all these guys together on a level of communication, a third level, a second level, this green one. And I explain this normally on a short example. Simon, please click. We have the specialists. The case behind this is to make a new electric engine for example, cars. and we want to reduce rare earth metals. This is the idea of the of the specialist in the electrical engineering, and he needs now the guys from production, from design, and so on. What is possible? Also, guys from business, and they have to communicate. They have to interact on this level of communication. And then they go back in their speciality, in their deep insights in these technical topics and also commercial topics, or also methodology topics. They work, and then the process is to come on a communication level from time to time. And I think COVID has changed this a little bit. This level of communication, in my opinion, if it's a digital level, can be used every day in everyday work. And so they bring forward this process. The key point is how the communication level, what are the key theories and the key ontologies of these communication level. And this is our concept that system theory based scalable and modular processes and methods can help here to build these interaction. And this is the one of the key sets we want to go in to this advanced systems engineering topics. Okay, go on. Roman? Simon, yeah. Oh, one step back. And Roman also explained, the next. Roman also explained this model. It's also a little play with the alphabet. Advanced systems engineering as advanced systems, as systems engineering, as an advanced engineering. Every of these three aspects is, in our opinion, very important. One example, what shows a little bit the future world, you see here the mobility as an example of a system of systems. Roman also explained a system of system is not a very big system. This is just a super system. A system of system is a system which has independent acting systems or agents, and they can work together, but they must not work together. And this system of systems approach is, I think, a very important point, and we will go in this world, and therefore we need answers. How can this come together, and how we can do with methodology approaches and way in this field. We know that we have different system levels, and we have to, one of the key factors of this system of systems is the validation. How can we clarify and make sure that these individual systems work in a system of systems level without making problems or damages, or without having very big risks, for example. And we need we have another challenge. Some of you who are in companies know it. We need cross-generational development and validation, because these systems are developed more and more, and we have always new generations of the systems, but we have to integrate them we have to understand them in this development. And here, for example, one approach is our X in the loop approach, where we simulate a lot of things and combine it with physical things. Okay, next part. Another aspect is the model of systems generation engineering. This is also a possible model. It's a proposal how we can model the interaction over the generations and cross-generational methods and processes. Here, a please click. Here we have to research, we need new methods to use all these informations and all these processes and things we have learned in the past for developing also the future. One model is here that we can describe this interaction about with a mathematical model where we combine the new things we want to do about variations from reference systems. And the reference systems can come from research, they can come from their own company or from somewhere in the world. Okay, this is gives us a chance to come to an integrated ontology and model of engineering. Okay, next part. One big aspect in these process we have to fix and to overcome in our methodologies and in our research is a very, very different development and life cycle time. Here it's just a very simple thing from mobility system as a system of systems. You know, software you can develop and change and test in 1 day or 2 days. If we have physical components on the level of cars, for example, or something like this, or mechatronical systems, we need weeks or months for testing and clarifying that the solution. And if you go to the infrastructure, I'm very active on this field. I have learned that infrastructure, not only in Germany, needs years of planning and also years of realizing this infrastructure solution. And then if the solution is established, then it has a lifetime of 20 years or something like this. And to coordinate all these interactions is a very interesting thing. Here we need agile concepts, agile solutions, and we are very much interested what you think and what could be your research to overcome all these aspects and make an agile development in this direction. Okay. Let us come to the aim of the workshop. Simon, will you do it or shall I do it?
You can do this slide.
Okay. So what is the aim of our workshops? What we want to do, we will ask you for existing models, theories, methods, processes, or approaches in the context what Roman and I spoke to you, maybe things we have already not found. We want to address them and maybe find some interactions. Then what specific research is necessary based on these collected approaches in the sense of the framework of advanced systems engineering. What can we do together and who can contribute to what? And the next part, how, also an important aspect, how will the curricula and the education concepts have to be adapted? What have we to do with the educational concepts on universities, for example, for development, for bring the future engineers in the right education position, to give them all what is necessary, and then at the end, last but not least, what are common research interests where we can work together. I think these are the 4 main topics we want to discuss a little bit with you in these upcoming workshops. Thank you.
Okay, thank you. So now I will tell you what is the idea, the structure of the workshop. And we have provided some sort of workshop tables where the research needs are already there, and there's a sort of structure matrix, and we will fill the columns by collecting the different models that Professor Albers mentioned. Then in the second step, we will make a short intermediate presentation. Third, we will then go into the specification of potential research questions and sub-questions and research topics based on the collected models and with the aim to address the research needs. And in the end, we will identify common research interests as a basis for connecting. And we have provided several of those workshop tables. And here's the link. I will put it in the chat, and then we get to the board where we are working. So, and yeah, my colleague also put it there.
So, wer ist jetzt hier? Aha. Wo sind wir jetzt hier?
Damit sind wir hier noch im Moderationsbereich, oder?
Ja, wahrscheinlich, ne? Herr Rapp, hören Sie uns noch? Schieben Sie uns jetzt in die Sessions oder wie geht das? Ja, hier ist ein Moderationspanel, ich sehe es da unten.
Ja.
Jetzt müssen wir wahrscheinlich warten, bis was. Roman, gehen wir immer mal abwechselnd in die Arbeitsgruppen, ne? Oder?
Ja, genau. Ich würde jetzt einfach mal so durchgehen.
Ja, okay.
Das glaube ich. Sind ja auch jetzt nicht so viele, habe ich jetzt gesehen, ne?
Nee, das ist ja auch zu erwarten, wenn du überlegst, das sind 8 Workshops und 160, 150 Leute. Ne? Das können also maximal 20 pro Tisch sein, sozusagen. Also das wäre schon viel.
Ja. Ja, das sind auch die Moderationen, ja. Ja, alles gut.
Wobei ich sehe den Dorian hier. Aha. Wobei ich habe bis jetzt noch nicht so richtig verstanden, wie wir jetzt an die Tische kommen. Aber vielleicht weiß das. Herr Raser, wissen Sie das? Hört er uns überhaupt?
Yes, I hear you. Are you able to hear me as well?
Yeah.
Okay, yeah, I think we kind of lost Simon, at least his voice, or just maybe me hearing him not at all. I think now everybody should join the concept board, which is a virtual whiteboard. Jonas Heimeke posted the link in the chat room on the right side. There you see the tiny URL. So please, everybody might join the concept board right now. And I hope.
Can you hear me again?
Yes.
Okay. Sorry. Don't know what that was. Okay, I see a lot of people already on the concept board. So here you see some basic instructions. And now I think as I'm using the moderation mode, I'm taking you all with me, I hope. And the first exercise would be to create a post-it with your name on it. You can do that by switching to the arrow here and then grabbing a post-it and
I think we lost him again. Professor Albers, Professor Dumitrescu, do you hear Simon?
Mr. Racer, do you hear us?
Yeah, I can hear you, but I can't hear Simon.
Yeah, that's the problem.
Okay.
Can you hear me now?
Yes.
Okay, sorry. Okay, first exercise, I see some have already successfully completed it. Grab a post-it. You can do that by switching to the arrow here, just then a post-it here. Then you can make a label with your name. If you want to grab it again, you have to switch to the cursor again. The idea is to make the groups. We go to the circle in the center here with the 6 parts, and then we will just put our label to the sector of the group that we are interested in, and by that we will see how the distribution among the people, among the groups is, and if we get a good number of participants for every group.
Mhm. Machen wir 3 Gruppen, Rob, oder wie viel machen wir denn jetzt?
I'd say let's see how the people distribute among the group. I think 3 to 4 groups, probably.
Okay. Das habe ich jetzt.
So just put your kind of label like my yellow one here, and then we will see who wants to go to which group. Yeah, so some are coming, yeah. So where's the rest? We have Francisco and Miss Mushik. Ah, yeah, so it's filling up now. Okay, so we have some people for complexity management. We have some people for innovative methods. And we also have some people for digital engineering. So I would propose, yeah, it's filling up now. Perfect. So how do you get to the group? You can follow the corresponding arrow here, for example, complexity management. This is your group table, and we have a breakout session in Hopin, and the link is always at the bottom of the table. So if you come to the respective table, and then if you go to the Hopin session here, that's our breakout session. And that's where you can work within your group. So the working board, it stays the same for all of us, because this allows us in the end that we can also see what the others have done. Mm-hmm. So now within your group, please make a short introduction round. We kind of skipped that in the beginning because it would have taken too long. Then the idea is to collect existing approaches, models, and so on that you know that could be a good basis for addressing the needs that you have within each group. And then also looking forward to the intermediate presentation, see if you find 1 or 2 persons who makes kind of a short wrap up after this first workshop slot. And then I would say we meet at 2:30. I think we can give us a little more time at that 2:30 in the main session again. So how do you get to the main session? You see, if you go back to the circle, there's the link for the main meeting. Mm-hmm. So the moderators, please have a look on the clock. And then I would say everyone, please join the respective groups.